Hello everyone. In today's class we'll be discussing modulation. Right, modulations are generally used or implemented or installed at transmitter end. Alright, at receiver end the reverse operation will be performed, that is demodulation circuit will be implemented. Okay, in communication we just do the modulation by changing certain parameters or varying certain parameters one wave on the basis of amplitude of the baseband signal. Okay, we will definitely discuss those in detail, how we are going to perform all that, as this subject is mainly focused on analog communication. So we'll be discussing an amplitude modulation type, frequency modulation and phase modulation in detail. All right, every time you'll be varying these parameters of carrier, right, on the basis of parameters of baseband signal. Like for AM modulation, we'll be changing or modulating the amplitude of carrier, right. Likewise for frequency modulation, we'll be changing or modulating the frequency of carrier, and in phase the phase is varied. All right, but condition provided is that while performing one type of modulation, other two parameter will remain constant, right. If I'm performing amplitude, the frequency and phase need to be remain constant, right. Likewise if I'm performing frequency modulation, then amplitude and phase they are they are maintained constant. Likewise for phase modulation. Okay, and the signal used to modulate the carrier is known as modulating signal, right. And signal what we get after modulation is called modulated signal. Okay, so there is a difference, it is modulating and here we get modulated signal. So I'll see these all things in detail. So before moving to definition of modulation, we must know all the terms associated with modulation process. Okay, so I'll discuss this baseband signal and modulated signal in detail. So first is the baseband signal. Baseband signals are nothing but the modulating signals only, or you can say the original information to be transmitted. Okay, it can be in digital form or analog form, right. Here we are concerned with analog information. Okay, because we are studying analog communication only. Okay, for example we have voice, right. It varies from 300 hertz to 3400 hertz. Okay, and generally we don't transmit baseband signals directly over long distances, but for short distances they may be transmitted, and this type of transmission we call it as baseband transmission. All right, next is the modulated signal, right, what we are getting after modulation process, right. This is the same baseband signal but shifted in frequency. Okay, actually the original signal, that is baseband signal, is moved to some higher frequency by doing modulation. Okay, and why we are doing that? To facilitate transmission. Okay, as I already said that baseband signals are not suitable for long distance communication. Okay, there may be some hardware limitations, interferences, channel characteristics and many more. All right, that we'll discuss in detail. Now let us see the definition of modulation, right. It is the process of varying one or more properties of periodic waveform, right. One or more properties of periodic waveform, that can be amplitude, frequency and phase, that I've already explained to you, right. And this particular wave is known as carrier wave or carrier signal. Okay, and these properties of carrier are varied in accordance with what? In accordance with the modulating signal. Okay, basically this modulating signal carries the information. All right, now there are different types of modulation schemes we are having. Okay, like first one we call as frequency translation. In frequency translation we'll have AM, FM, PM like techniques, right. Then second is sampling and coding, in which we'll have PAM, pulse amplitude modulation, likewise pulse code modulation, etc. Okay, and finally the keying techniques. Okay, sometimes we call them digital modulation techniques also. All right, so these are ASK, FSK, PSK, QPSK, QAM and many more, right. Amplitude shift keying, these are quite similar to these techniques, but but the information content here is digital. All right, now coming to a very important topic, why we need modulation? See, the first point is the size of antenna, right? The size of antenna generally depends on the lambda of wave. Lambda is the wavelength of a wave, right? Now suppose you want to transmit this waveform, okay, and its wavelength is lambda, right? So you'll require an antenna of height that is equal to lambda, right, to transmit this waveform. If suppose for example, and you know the lambda is v by f or c by f, where c is the speed of light, right, and f for example I have taken to be 20 kilohertz, okay. Now if I put these values in this formula, so lambda will become equal to c is 3 multiplied 10 to the power 8, right, over f is 20 kilohertz, so 20 multiplied 10 to the power 3, all right. So this comes out to be 30,000 by 2, all right. So 2 15, right, or you can say 15 kilometers. That means an height of 15 kilometers will require to transmit this wave, right, of frequency 20 kilohertz, all right. This is not at all practically feasible, okay. Now this brought trouble to designing engineers, right? So they again decided to analyze this waveform, okay. So let us see what they did. Now with advancement of technology, the engineers actually observed that if suppose you have this sort of waveform, right, you know this and this side is exactly similar but opposite in polarity, right. This side, if it is a sine wave, this is having a value 1 and this side is -1. The amplitude is same but change of sign, okay, our polarity is reversed, right. So their observation was that if we use only the half portion of this thing, right, that can make our job done, we'll replicate this thing twice at receiver end and we'll get same thing, okay. So this reduced my antenna height by 2, right. If I have suppose 15 kilometers of antenna height, then I'll divide it by 2, okay, and your antenna height will certainly drop to 7.5 kilometers, all right. But still it is not feasible, okay. So what we did, we just analyzed the waveform further, okay, and what we found that it can be regenerated, this whole waveform can be regenerated by having only the lambda by 4 of information, okay. So this whole thing is divided by 4 now, okay, and this certainly reduced the height of antenna to 3.75 kilometers, quite effective, okay. Instead of 15 kilometers, we now have a value much less than 15 kilometers, that is 3.75, okay, but still the job is not done, right. So this decided to work on another parameter, that is the frequency, right. If we can increase the frequency, we can reduce the height. That was the idea, okay. So as you can see in this example, the frequency we have considered is 500 kilohertz, right. The speed of light is the same because we are using EM waves, okay. So your height of antenna will get reduced to 40 meters, all right. This is quite feasible, right. So this is the one thing why we need modulation, right, to compensate for height of antenna. Next thing why we need modulation is the radiated power of antenna, okay, which is given by this formula, right, where P is inversely proportional to lambda, you can say, or lambda square, you can see, right. So as my lambda decreases, I mean if I'm increasing frequency, I'm doing modulation to increase the frequency only, right. If I increase the frequency, my lambda will go down, right, and ultimately this power radiation will increase, okay. More the radiated power, more will be the distance covered, all right, or you can say the length of the transmission is more, okay. Now next thing is the next point is the channel characteristics. Channel is something on which we are transmitting our signal, right. So you can see some characteristics here, right. This is frequency domain representation, this side is frequency axis and this side is amplitude. Now you can see this region is the lower frequency region, right. This is the low frequency region, and this region above this side or this side, on either sides, it is high frequency region, right. These are the general characteristics of your channel, right? Channel basically attenuates all the values, or after some time it will get attenuated. Your low value signals can get attenuated, right, due to resistance offered by channel. Okay, and it will allow the high frequency signals easily. That is again one reason we are shifting from low frequency region to high frequency region, so that we can easily transmit on channel. Okay, and that too with minimum of losses. All right. Another important application of modulation is the multiplexing. This technique actually ensures the effective utilization of one channel, right? In here, we can transmit multiple number of signals through common channel. Okay. In British era, the channel was dedicatedly allocated to single user, right? So no other user can transmit or receive any signal from there. At that time, it was not possible to analyze the bandwidth of the channel, right? And this analysis was made possible due to tools like Fourier transforms, Fourier series, okay, which made this possible to analyze a channel in frequency domain. All right. This way, we can actually analyze the capacity of transmission channels, right? So multiplexing actually makes use of this information and transmits multiple signals with different center frequencies or different carrier frequencies at a time. Okay. If you see this picture, here you can see we have one signal xt, and xf is its frequency response, right? So this is the spectrum of this signal. All right. Likewise, this is a spectrum for yt. Okay, and you can see they are being transmitted over same frequency, means the carrier frequency is common, 100 hertz and 100 hertz. Okay, so ultimately, because the center frequency is same, so they'll get mixed up, and the actual information we have 5 volts here and 7 volts here, so it will get added up and the information content will get changed, right? This is nothing but the interference. So what we do in multiplexing, we actually maintain the center frequencies at different levels. Like suppose this is 100 hertz, then next will transmit with 150 suppose. Okay, another signal will transmit with 200 hertz, and this way will achieve this thing. They can travel simultaneously on same channel without interfering with each other. That is multiplexing. All right. Or in other words, you can say that we are modulating your signal with different center frequencies. I think you got it. Next is we can separate signals from different transmitters, right? We know the audio frequencies are in range 20 hertz to 20 kilohertz. This is the baseband range. All right. And if we transmit this signal all the time, so all the signals will get mixed up and nothing will be or can be recovered. Okay. Now suppose we have two signals with same frequency, and these two are to be transmitted to some point. Now by modulating them, I'll shift this frequency to suppose 500 kilohertz. All right. And this frequency I'm going to shift to 1600 kilohertz. Right. Now as the center frequencies are different for two signals, we can easily identify them and receive them by tuning our circuitries to that dedicated frequency only. Okay, so that is another advantage from modulation. Then we have increase in the range of communication, right? This is somewhat related to the channel characteristics and the power radiated. All right, if we are modulating, obviously we are switching to some higher frequency from baseband frequency. Okay, so we have already seen the characteristics, channel characteristics, that high or heavy frequencies or higher frequencies will get less attenuated in comparison to low frequencies. Okay, and obviously the radiated power will also get increased. So this way we can increase the range of communication. We have modulation schemes like FM, right? They offer better or very high signal to noise ratio. This will definitely help in improving the reception quality, right? That is why the effect of noise is greatly reduced in schemes like FM, and even PM we have reduced the noise up to some extent. I mean, it is better than AM, but less than FM, right? Then we have one more advantage, that is reduced bandwidth. The frequency domain information made it possible to determine the bandwidth and to work for reduction of bandwidth. We have modulation techniques like VSBs, SSBs, right? Here we have greatly reduced the bandwidth, right? So this is made possible due to this information, this frequency domain knowledge, right? And these modulation techniques are helpful in bandwidth reduction. Okay, they nearly reduces the bandwidth to half. Okay, so that we can make effective utilization of your channel. All right, so that's all for now. Thank you.